array stores element in contiguous memory location. So sometimes you have to insert element into the array without necessarily changing the index position of the other element. So in this class, I'm going to teach you how to insert an element into an array, right? So insertion of data into an array, that's what we want to do in this class. So without wasting much time, let's begin. I don't want you to forget the concept of the logical environment and then the physical memory. So that you have to be very careful. Now, let's say I have my array, right? Array stores element in contiguous memory location. I have an array, say 1, 2, 3, 4, 5, 6, 7, 8, 9. So I have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So that will be what? I put 10 here, 20, 40, 50. So here, I don't have anything here. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm declaring an array for 10 elements, but I'm only supplying 4 elements. So the remaining space will be what? Wasted, empty. So this is the advantage of an array. It's fixed. Once you declare the array size, even if you're not using up to that, nobody can use the remaining memory space. So, but in this case, I'm doing this because I want to what? Insert an element. Let's say I want to insert 30. So that my array will become 10, 20, 30, 40, 50. So I'm inserting this, right? So that will be at this index. Do you understand? So that will be at this index. Now, for me to be able to insert this 30 into this place, I have to shift this 50 to this place, shift this 40 to this place, then insert the 30 there. So that is what I want to achieve. How am I going to write a program for the computer to be able to do this? So I'm using C language to implement this, right? So we are still doing data structure and algorithm, but I'm using C language to implement this data structure. So in this case, now we are dealing with array. So let's write a program to do this task for me. So using C, I'm just going to bring in my library, include stdio.h, standard input output library. So this is where I'm going to pull out my printf function. You know, I'm always using this printf. So this function. Since I did not write the code for this printf, where is the compiler going to see it in order to use inside this library? So then I will start my main int main. So this is my main function, which is where I'm going to carry out my activities. So inside this place, I'm going to declare my array. So I'll say int, let's call it array, right? And I'll give it a size, which is what? 10. Then this is declaration. So once this is done, 40 bytes will be allocated. 40 bytes will be allocated because 10 integers. An integer is what? 4 bytes. So 4 times 10, that is what? 40 bytes. That is the size of the memory that will be allocated for this array. But I'm only going to supply 4 elements. So here I'll put 10, 20, 40, 50. Right? So that is that. So this is where it's stopping, right? I don't want to clean it because I want to use to explain. So this is my array declaration, stopping at this point. Now, I need to also tell the system that I'm supplying only 4 elements. So that is why here I will declare int n, and I will say 4. So I'm supplying only 4 elements. Then I will say int pos, that is position. Where do I want the new element to be inserted? At index 2, right? Which is what? This position. Okay? Then int value. So the value that I want to supply, I can ask the user to put in the value at runtime, but I want to hard code it into the system. So I'm putting here 30, right? Then I'm also going to declare another variable int I, which is what? My loop counter. Because I know that since I know the number of elements, I will use a for loop to carry out, to give the instruction. So the guy that is going to do the checking is this I. So that is the loop counter. So I'm going to initialize, I'm going to declare it here. So this is done. Because I want to insert 30, right? I want to insert 30. I have to shift this guy, then shift this guy, so that I will have space to insert the 30. So I'm using a for loop. I will say for. Now, I'm going to initialize this I. Assign n. So this n, which is 4, I'm going to assign it to I. So I have I here, so 4. So my index is pointing to this place. It's pointing to this. This is the index, which is this guy. So that is my I. Then I'll have a condition, I greater than position, which is what? This 4 is greater than what? So I have another one, which is the position. So position is what? 2. Right? So 4 is greater than position, that is true. Then I have my increment. So, but this case now I'm doing decrement. Minus, minus. I will explain. So I'll put this. Now, inside this place, what do I want to achieve if this condition is true? If this condition is true, come in and say array I, array I minus 1. Meaning I is what? I is 4. So 4 minus 1 will be what? 3. So that will be what? Array 3. Using the formula I gave you on one-dimensional array, how to locate the memory address, it will calculate the memory address for this array 3. And that memory address will be what? Will point to this place. Right? So when it gets to this place, it will take the value that is here. That is what that line is. It will take this value and assign it to array I. So array I, which is this, is what? 4. Right? So it will calculate this address. It will come here, take this value and put it here. So it's moving this guy here. But it's copy. It's going to copy this 50 into this place. So assuming I'm to print out the value of this array, to print out 10, 20, 40, 50, 50. That's what will happen. So it has copied this into this place. Then I will close this. So it will do that. Then it will what? Decrement this to what? 3. So this guy becomes 3. Then it will check 3 is greater than position. 3 is greater than 2. That is true. It will come in again. Then this place will become 3 minus 1, which is now what? 2. So it will check here. I will calculate the address 40. It will move that 40 to this place. So it will copy it to this place. So here will be what? 10, 20, 40, 40, 50. That's what will happen. Then it will increment, it will decrement this again. So it will bring this down to what? 2. So I is now 2. It will check 2 is greater than 2. That is no longer true. So it will come out of this for loop, right? It will not shift anything again. So it will come out here. Then, since I have moved this to this place and I've moved this to this place is still carrying 40 though. But this is where I want to insert my value, which is what? 30. So since I have the 40 here, 50 here, I can override what is this place by inserting my what? My 30. So there I will just write, I'll write array position, which is what? 2. Assign value. That is what is inside this place. Insert it into this place. Once that is done, so this array becomes, this place will become 30. Here will become 40. Here is what? 50. Right? Now, how many elements do I now have inside my array? 1, 2, 3, 4, 5. No longer 4. So I have to increment this n by doing n plus plus. It's very important. If you don't do this, then when you are printing out the array, you will still not be able to print out this 50. Right? So I have to increment, telling my computer that my array size has increased. So I've increased the element to what? To 5 instead of 4 that it was initially. So having done this, I've done my insertion. So I want to print out this my array on the screen. Let me come here so that you'll be able to see. So I want to print it out. So I will say printf. So what should be under this place, what I'm putting here? Printf array after insertion. Right? Then I'll use my for loop again. For I, this time around, I'm bringing I to 0. Right? Because I want to start counting from here. I less than n. Because my n now has increased to 5. I plus plus. Right? So inside this place, I'll simply print f %d, comma, array I. Then I will close this. Then I will say return 0. So this, my curly bracket, I'm closing it here. So that is it. So this is my program on how to insert an element into an array. So I have explained them to you. So I declare an array 10, then I'm giving only 4 values. So which was initially 10, 20, 40, 50. Then I'm telling the computer that the element I'm supplying is what? Just 4. And then I'm creating a memory location called position, that is pos, for index 2. And int value, another memory location again, for the value that I want to insert. Then I'm declaring this loop counter. So I'm assigning this my loop counter, meaning come to the last place, which is here initially. So if it is higher than the position, come in, insert what is in the previous location, insert it into the, that means I'm shifting. Shift this to this, shift this to this. Then you have the empty space. When the condition is no longer true, come back here, assign value to that position. Then tell the computer that your array element quantity has changed. Then print out the array on the screen. That is what I just did. So let's go to code blocks. Let me demonstrate this for you to see. Don't forget to give me a thumbs up if you have come with me this far. And if you have not subscribed, please do so. And also help me to share this video so that more students will see it. Let's go to code blocks. So this is our code blocks. This is the script, just as I demonstrated on the board for you to see. So all I want to do now is just to execute this script for you to see how it's going to work. So I'm going to execute it. So you see, this is it. Now, this is the array, 10, 20, 40, 50. That is before insertion. Now, after the whole process of insertion, where this is going to happen, what will now be printed out on the screen will be array after insertion, which is array after insertion. So it's just going to print out array after insertion, then it's going to populate the array on the screen. And that's what you're now seeing, which is what? 10, 20, 30, 40, 50. So it has inserted 30 into the array. So that is what I want to show you in this class. If you have come with me this far, don't forget to give me a thumbs up and also help me to share this video. So till we see in the next class. Bye-bye.